Hi everyone, my name is Wasim Kareem and I'm going to be talking about Bitcoin and the blockchain. I'm going to start off by talking about HTTP status codes and status errors. We've all seen 404 errors, 403. One little known error from the early days of the internet is the 402 error, which initially stood for payment required. And at the time, it was thought that there would maybe be a digital currency that came along, so that was thought to have been reserved for that purpose. Well, that didn't happen for a long time, and part of the reason why is an inherent problem of how do you create trust on the internet? In a system that's inherently untrustworthy, how do you create trust? In particular, a couple of particular problems. One is, how do you create digital scarcity? So scarcity is a property that's inherent to money. Money has to be scarce. How do you create digital scarcity where things digital by their nature can be copied and distributed? And secondly, there's a problem called double spending. So if I have $10 in an account and I try to spend it several different places at once, immediately spend it here and then try to spend it several other places, everyone's saying that I have $10. Who determines which transaction happened first? So we've had to rely on trusted third-party intermediaries, the PayPals and Visa, who have ledgers that intermediate these transactions and make these determinations. So then in January 2009, Satoshi Nakamoto, whose identity isn't known, released Bitcoin software as open source in January 2009. Bitcoin is a digital currency, a cryptocurrency, currently about 15 million in existence. The protocol caps the total amount at about 21 million, but each Bitcoin can be subdivided into many units. And so Bitcoin runs on a distributed network with no central authority. So each node in the network maintains a copy of the ledger, the Bitcoin ledger, which is known as the blockchain. So this enables peer-to-peer transfer of value through the distributed ledger. The blockchain in Bitcoin has been called a protocol for trust on the internet. And what does that mean? It's essentially a standard and method for things of value to be exchanged over the internet without the need for a trusted third-party intermediary, because the protocol itself is inherently trustworthy. Just like exchanging, if I were to hand Ryan a $10 bill, that process is inherently trustworthy. Brian doesn't need to trust me. We don't need to bring in a third party to verify the transaction. The transaction itself speaks for itself. So how does Bitcoin work? As I mentioned, the blockchain is a transaction ledger, and Bitcoin transactions occur through a public and private key pair. So there's an address on the blockchain ledger, which is the public key. That's the public address that receives inputs. That's a publicly known address, and it's associated with a private key. This private key is known only to the owner of the Bitcoin, and it's necessary to generate an output, to send money. So whoever has access to the private key can spend whatever Bitcoin is at the associated public key. The way Bitcoin is sent is the private key is passed through a signing algorithm along with the details of a transaction, which is the message. Those form a digital signature, and that digital signature, when combined with the public key, can be passed through a verification algorithm, so the nodes in the network can verify that indeed the private key associated with certain public key was used to generate the output, and that the public key had the sufficient funds in it. There are various nodes listening for these transactions on the network, and they're grouping together transaction details in blocks, and that's how it gets named blockchain, which is the public transaction ledger, and it's a linked list data structure. So essentially what the various nodes are hashing the transaction details. So we have here, they're listening, the nodes are listening for transactions, and then they're hashing the value, so they're getting a hash value. Those hash values are then combined with the hashes from other transactions and so forth until there's one combined hash value for all the transactions in a certain block, which forms what's called a Merkle root. So each block on the blockchain has a unique hash value to it. That's essentially like the digital fingerprint, the ID for that hash block. And that's made up of several different things. One is the Merkle root transaction hash of all the transaction data. Another component to form a block's hash is a timestamp. The third component is the previous hash, which is the hash from the prior block. And then a fourth component is a nonce, which I'll explain in a minute. But essentially, by incorporating the hash from the previous block, these blocks are all linked. So if any of these transaction details are altered or forged in any way, the entire hash for that block is changed, which then changes the hash for all subsequent blocks. So essentially, this is a way to ensure that the blockchain is tamper-proof. Because as we know, if any details, if the hash changes in the slightest way, it completely changes all the hashes. So this is sort of a mechanism to ensure that the transaction details aren't forged. If any of these hashes change, then the other nodes on the network would recognize that it was not a valid copy of the blockchain and reject it. As I mentioned, there are 4 parts to form a block's hash. One of those components is a nonce. The blockchain is an immutable distributed ledger that's maintained by all the nodes in the network. But then how do blocks get added to the blockchain? As there are all these transactions happening and they're being arranged in a block, the problem I mentioned earlier of double spending, which transaction happens first? How do you get all of these nodes to agree on one version of the blockchain? And that's accomplished by something called mining, Bitcoin mining. Bitcoin has a proof of work scheme. So essentially, as the miners are grouping together transactions, they're combining it with the prior block's hash, and then they're essentially trying to figure out the nonce value, which is a piece of data that's unknown, and they're essentially trying to figure out what that value is to get some sort of expected hash output. So they're trying to figure this out, and they're essentially engaging in a cryptographic race. They're racing to try to figure out, to try to generate the expected correct hash output. So they're plugging in different nonce values. They're running it through a hash function, which is the SHA-256 hashing algorithm, and they're trying to get a expected hash output, which has a certain number of zeros. So they're expecting to get some sort of hash output that has a certain number of zeros. They keep doing this, and whoever gets the correct hash output essentially wins this race, and their block is chosen to be added to the blockchain. Since cryptography is used, all the other nodes can agree that this person did the correct proof of work to generate the correct hash output, and those transactions are verified into the network. There's actually this website here is like a blockchain explorer, which kind of shows the details of the blockchain. Here are the transactions that are happening sort of in real time, and you can click on a block. This is a block. And you can see has the details. Here's that block's hash, which you see all these zeros, which proves that they did the necessary work to come up with this hash. Here's the hash from the previous block, and then this is the hash from all the combined transactions, and that's essentially the last few blocks that were solved on the blockchain. So essentially, so we have a Bitcoin, and the blockchain is a protocol that allows for value to be communicated over the internet, and the implications for that are pretty significant. So we have any device that's connected to the internet is now capable of sending money and value over the internet the same way data is sent. And there's a lot of things that can be done with this. So we now have the ability to write and deploy code that sends and receives real-world value without requiring any permission to innovate. Bitcoin has been called the Internet of Money. The same way the Internet changed the way we communicate through a decentralized network, Bitcoin allows anyone to participate in transferring value without requiring third-party intermediaries' permission to innovate. And there's a lot of applications beyond currency and Bitcoin that this blockchain technology can be used for. There's a lot of interesting things in the work involving stocks, land records, titles, digital assets. Like land records, for example, can be put into this immutable data structure, and especially in countries where land records and title chains may not be reliable, this is a easy to implement way for land records to be immutably stored. There's a lot of neat things going on with Bitcoin. Currently, JavaScript's own Brandon Ike is the CEO of a company that has a browser that sort of proposing an alternative to the ad-based system we're used to browsing. And his browser, the plans are to have it loaded with a certain amount of Bitcoin, so when you visit a web page, it can actually send Bitcoin to the content provider. Something like maybe a fraction of a cent or pennies, something that would not be possible with credit cards or any other payment system, because it's not feasible to charge credit card 3 cents. But when money and value can be transmitted like data, it's something that can be exchanged behind the scenes. And for content providers that are getting lots of hits, it can add up to a viable alternative to advertising. So there's a lot of neat things that can be done with value being exchanged like data, and it's something to think about as we move forward.